We can show how many electrons are in each sublevel by drawing an energy level diagram and filling in the arrows to represent the electrons. But we would really like to have a shorthand method to list the electrons and their sublevels. That shorthand notation is called an electron configuration. There are different kinds of electron configurations, so we will start with the simplest and move towards the most complicated. We saw this energy level diagram for silicon earlier. We could say that silicon has a 3p2 configuration. In this language, the superscript indicates that there are 2 electrons in the 3p sublevel. We can also find this configuration from the periodic table. Silicon is in the p block, and we can determine that the highest occupied orbital is 3p. Notice that it is the second element into the p block in that period, so there would be 2 electrons in the 3p sublevel. That gives us the configuration 3p2. The other item of interest here is the number of unpaired electrons in the highest occupied orbitals. Going back to our energy level diagram for silicon, notice that all of the electrons in the levels below 3p are paired. In other words, for every up arrow, there is a down arrow paired with it. More technically, for every electron with a plus 1/2 spin quantum number, there is an electron with a minus 1/2 spin quantum number. In the 3p sublevel, there are 2 electrons that are unpaired. They have the same spin. We would say that a silicon atom has 2 unpaired electrons. We notice that to determine the number of unpaired electrons, we only need to look at the highest occupied orbitals, since all of the electrons below those on the diagram are paired.